deep dive quickly because I don't know from where I will get this 15 minute, but let's try. So this talk actually, it's about concept of designing REST API. It's not related to any kind of programming language. Even yes, I'm working with Java. I love Java and Java Champion and da. But this is really something that I get inspired by the way that I code review the designs for our architects and the developers, and how I see that they are really designing the API, especially if you are in bolt-on strategy working project, green project, or even brown project or legacy projects, but you're trying to provide the services and integration. So this is all about, so there is different concepts from design, from using HTTP concepts, from even how to make this API not restful, because there is a big difference between both. It's continuation, but usually people do REST and call it RESTful. And the other side that, yeah, RESTful is painful, so let's switch to GraphQL completely. And no, I will like gRPC. No, I don't like SOUP. Like every single pattern, it's usable. And there is nothing replacing others. We have to know which business case we are using and then trying, because if I had this case, like I was consulting a company and they just, when I consult, like, why you have federation here and why everything, like why this is not REST, like we use the graph, we heard it in conferences, so we decided to use graph for everything. So it becomes so complex. You don't need data mutation everywhere. And sometimes in communication between two services, why you even use REST, why you don't use gRPC, especially if you are inside your zone. This way, you are connecting with legacy system or very secure platform integration. They use SOUP. You don't have to push them to expose REST API. You have to think about this business cases. But the main problem, don't develop monoliths, use everything microservices. No, both of are patterns. We used it based on the specific on cases. This is something that I would like just to emphasize very importantly, because I have this always as a question when I consult. This is why it came from effective design of REST API. And actually, I get a lot of people like, why are you giving this talk? It's already obsolete. GraphQL replacing. Can you imagine this kind of questions, or even people trying to encourage me to not to give the talk? So I'm working as a solutions architect. This is, I will bring it back to you. You can communicate for me, but it's much easier. Google my name and you will have everything. So it's easy to catch me on LinkedIn, Twitter, whatever it is, and you can ask any questions. All my projects, concept and everything is already on GitHub. So I write frequently for Java Magazine, so you can check about, but it's more about Java and main concepts. Some publications I did, so let's go into our agenda. So what we are going to speak about today is just, we have to know some tips for modeling. Before I jump into the code, how can I start modeling our application? Our requirement. From the requirement, I would like to build all the URLs, the verbs, everything. So which language, it doesn't matter. You have the design. You can communicate it to your front end or testing team to start build their front end or test cases, and they are pretty sure that you will not change after that. Then you go for your back end, you start building your stuff. And in order to build this API and know the tips for modeling, we have to know who is using our systems, who we are providing this functionality. This is very important. And then, okay, we saw all the requirement, we revalidate it, we shuffle it, are we really satisfy all the requirement that we have to serve, that should serve our customer? This is where it comes to validate your API. It's very slow when I use this, sorry. So after that, we have to know, okay, now it comes to the actual design. I knew a requirement, I laid out all the API, the URLs, but which kind of codes that I have to use, which kinds of HTTP attribute in order to give it to my customers so they can understand the status about the payload and API and everything. And this is like something that we have to agree on, because we are misusing things usually. And then now we need this API to be RESTful. So how to transfer it to RESTful API, we have to consider this kind of pattern in our design. How to make our backend is client server, pattern, how it could be stateless, and it should be, and cacheable, how it could be a layered system, and also we can introduce code in demand sometimes. This is the optional part, and the most important is uniform resources. This is where it comes that all big companies work with this. We will examine them, so let's go. Any questions? No questions. Let's. So there is always 3 approaches to add an API, because we are working project, or either you are joining new project, which is really funny and really nice because you are using new technology and everything, but most of the time you're joining, you know, brownfield projects, which is already existing. And the more worse is that you are joining company that has legacy and want to transfer all these legacy systems into new something functional and runnable to catch the new trends. And some, like, you join pension project, old banking system project, and they are running COBOL or AS400 or something like this. So it's not the same mindset, but we will see how it is. But before we deep dive, okay, API design is not an easy function that we have to look at, because we have to think always what functionality you would like to expose. Always this is question for yourself, how to expose it and how the best way to expose it, because you can expose it in a complex way, and it's always harder when you make things simple. Simplicity is a key, but it's the hardest way to provide your functionality. Instead of designing 10 URLs, you can reduce it to 3 or 4, still do the same functionality, because you are revalidating, revisiting your design until you reach this is how exactly it should be. It will be very easier for your customer and developers or integrators that would like to use your API. And then this is how it comes. Some of the audience here says like testing, which is improvement and validation of adjustment, even not from the first step, second, third. Always have this in your mind, adjustment and improvement. So as we know, design is hard. Also one of the most debatable things, which is naming things, and you know, naming and cache invalidation. We never agree, but naming is the key to have self-documentary URLs, self-documented things that when I read it, I know what is the functionality I'm expecting. I don't have to go through the whole documentation. When I consult all the API, just when I call it, I call the root of your service, I will get the whole API. I know when I call this, I do this. When I call this, do this. Only I need to read about the payload, or what HTTP status codes that you're gonna give me, or exception or something like this. But naturally, when I look at it, I know which functionality you can give it to me without going further into documentation. So naming, we will see this in uniform resources. So we have in computer interaction design, concept of design, we have something called affordance. Affordance, when we design product actually or something, affordance is something that allow you or the customer to accomplish something. And this is really, it's a very important concept in design, and it will affect us. Like when I'm designing door handler, the main affordance of this door, like when I grab it, it's comfort for my hand, and I can just turn it right and left to open and close. This is the only thing that it should do, not multiple things. Don't overthink. Same like switchers. So we love coffee. If we take affordance in practice, we have to think it like this: what API will allow you to do actually, and what the API makes it easy for you to do, and what user want to accomplish, because you don't have to provide functionalities that doesn't make any sense. Or in the future, don't go for the future. Requirement says do this. Like if you have a requirement that 1 in Roman I equals 0, I will just have a function return 0 when I receive I. That's it. I will not do switch cases and search for nothing. This is the requirement. It does the job, right? When the new requirement comes, I will extend my functionality. Less bugs. Coffee cups, when we design it this way. We love coffee, we love tea, you know, but we have handler. Why the handler? It's great because it designed it to not burn your hand, and also we can use it for something else. Sometimes you can use the same functionality in some orders to make use or to expose more functionality, but you discrete it like small function that I can combine with others. As our example we will see, then we provide more functionality. So you have to always think small version. Then you can make use of those, and then improvement, it will be very easy. If you provide one function that has many functionality, you know, when you change something, it will affect the others, then you have a lot of code base that you need to change accordingly, and they are not even related to each other, just extracted. One thing at a time. So adding an API. Now we knew about the concept, we know what we need to expose, how it's easy, we have this kind of mentality. Okay, now I've joined the team and I would like to add some APIs. So we have something called bolt-on strategy, and this is brownfield. Sometimes we like it if it's new, but some other times we don't like it but this is the majority of the project ongoing. So what is the advantage? This is a brute force application, but generally is the fastest way to get something really useful. Why? Because it's already running. And it takes advantage of existing code and systems, but it has a little bit disadvantage that problems could leak into your API, which is bugs. Because you just try to wrap and expose the function. And then you have to think about the API and the bugs that you are introduced into your system. Greenfield, it's always the new ground project, but this has to has a mentality of mobile first or API first, which I'm designing the API and serving the customers first. So I think about the API, how the functionality could be achieved. I'm not thinking about the back end or the data or something. I'm designing the API first, and from the API I will derive all the functionality serving those API. And this way the customer knows, you know, what to expect, validating the functionality. Yes, I need to do all of this if it's e-commerce or whatever it is. And then you start working on that. The front-end guys know what should be done, and the back-end knows, and the QA team knows. And then you come to testing, they prepare the test cases, the guys finish just for integration, and it will be much easier. And definitely you will take advantage of the, you know, the team using new technology. You are integrating your team as possible as you can, but not always the possible driven business, because you have to take in mind lean development or, you know, MVP, in order, just because you need to catch the market. So it's always comes with different mindset. The last one is facade strategy, and this comes with wrapping existing logic, replace as you go. And this is suitable for legacy systems because they are always functional and less buggy. So in this way, you can just, you are building, you know, like facade, exposing because they are not, or adapters in the middle, and then you expose the REST API. I had this when I was working with pension in Egypt, and it was COBOL based, and you don't have anything like how can I expose REST. So we have some tools that just plug in the COBOL in, and I asked the guy to give us like interfaces, functions, and this function by specific tool R to Z IBM tool, just plug it and expose it as a REST API. There is a plugin that you write to do this transformation. But we exposed it because we need a mobile application. We're trying to modernize the pension application to provide web applications for the pensioner people, so they can just don't go to the office and can do all the transaction from their place, or integration with banks for ATMs, so you don't have to go to the office to get your pension. So it was a big hit, but we faced a big problem, which is, you know, mentality of the people. They doesn't understand you, because, you know, people working on this kind of stuff, there is a function running, get result, and that's it. You need a report printed. So what's your problem? Yeah, I need to expose it, but it's function. Yeah, we need it in this way. So you have to adjust yourself. Knowing how we can work on projects and how we can add our API, we need to understand how we make it successful modeling. So we have to go through a specific process, but just let me tell you some stuff that I want to lay out here, some simple rules, because I found a lot of developers waiting to learn new tool in order to model, you know, specific design tools or whatever it is. But don't worry, pen and paper, notebook, sticky notes, just write what you want and then shuffle later on. So it doesn't matter, don't stuck with the tool. And then we have to have a consistent process, and this way we can revisit and validate. We will see this consistent process. And definitely don't go for like, don't document, it's not required. It doesn't count unless it's written down, because if you didn't write, you're sitting with the customer, you talk to him, you have all the requirements, you go to the office, you lost 20% of the conversation. You wait for tomorrow and you didn't document, you lost more 20%. Then when you speak to your team, you're talking about 60% if you have a good memory, which is this is the nature. When you go out from this speech, you will have only 30 to 40% knowledge, but you have to consult back. So how to do this? Write down or record. This is very important. So you can just or have some usually go with my analyst and he can write down. He's faster than me, and this is very important. And then when you document everything, you can deprioritize it later on. So I know now I sit with my customer and I would like to design, and I have the tool. I wrote down all the requirements and everything. I'm doing prioritization, so I have to have a small persona about my customer, who they are. Are they external or internal? Why you are asking these questions? Because of the security concerns, because the functionality, how they can access my APIs and these kind of things. And just write short description about them so you can understand their behavior. So let's take a coffee cup example, for example, or coffee shop in a small version. So if we are visiting coffee shop and we would like to have visualize some participant, we have patron, which is you, going to ask for a coffee. We have cashier, we have barista who preparing, and some other customers surround me asking for. So now we know them, and I would like, okay, what is your interaction with my system? I have to identify activities and break them down into steps. So I'm taking you from requirement until we reach the final URL, and you will see why those steps are relevant. And most of you I know that know this, but I'm just emphasizing. So what is our activity? That you place an order, you wait for the order, and you receive the order. So this is all the activities that we have. But do you think this is complete? Definitely it's not. Why? Because as I mentioned here, I'm describing you as a patron. Where is the barista? Where is the system? Where is the other customer? Where is the the cashier? I don't see interaction. Who I'm like, you placed an order with whom? So revisioning and revisiting, I will come up with the patron, which is you, create an order with the cashier, and then the cashier passes the order to the barista, and the barista acknowledges the order and add it to the queue. Oh, okay, we have a queue here, we have to maintain it, because this is how we can get the orders in order. And then an order, while it's a process, there is something else came up. We didn't see it at the beginning. Inventory and machines has to be tracked because the suppliers. And also as order are ready, they are announced and delivered to the customer, and the customer receive their orders. This way, sometimes when you list all the participants, not all of them are relevant to your system, but at least know all of them. Then you start to see the activities. No, those are not into our system, we will exclude them, and those are the list. Here is the all activities, they agree, we are done now. Let's move to the next technical part. So this is how I write it down literally on paper and just whip it. No, there is still one more, 3 or Word document. I usually do it in Word document, even the design. And you will see it very simple. Now we identify the participant activity for book online, another example, and we will go with this example to the end. Participant, if you would like to see, like we have system admin. System admin, what does it do with book online? They are part of this. We have developers, customers, and customer support. And the activities for short, after like engaging all, we have a functionality for placing an order, look up an order status, we can cancel an order, add item to cart, remove item from the cart, clear cart, and checkout process. So those are the activities that all the participants will be involved in. That's nice. I know all of them. Now I need to create and group the API methods. I know who is going to use my system, and I know the activities. So what is the resources out there? Resources which form our URL. In this way, we need to create and group our API methods. So the consistent process that I go through always is first identify the participants because they are key player here. And then identify activities with the system requirement, how you would like the system function to serve them. And you revisit, as we did for the first example. Second, break into smaller steps. So one function at a time. And then I revisit. And then I create the API definition, which is the technical part for us, which is the design part actually. Without going into technical detail, the language, the feature, no, I don't care about this. I care about the final contract that I will give to my colleagues or teams to work with. And I revisit, and the most important part, which is our test plan, validate your API. We will see the fourth and fifth step now, because we have done first, second, and third one. Any questions so far? No? Let's leave it at the end, because the time. Are you sleepy? Are you good? Focusing? Good. Let's review, just because maybe you lost. Here are our participants. Those are our activities. Let's create a group. So to create an API definition, definitely we have to identify the resources, and your resources are usually the nouns exist in your activities. So the resources that here we have item resource, and item I would like to do some actions. I would like to list items, view items, search items, and add and edit items. Okay, these are the functionalities on those items. Thank you for upgrading and using my internet. We have the cart. The cart, I need to add an item inside the cart. Yes, because I would like to buy. Remove an item, clear, view, check out. Those are the activities on those resources. And then we have order, right? I would like to list order for customers, obtain order status, and cancel an order if they would like. And finally, I have the customer himself. Like I would like to view the customer, search about the customer, and edit and add customer. So those are all the resources. Now I know the activities, I know the resources, and okay, what else? What next we should do? What next is very important is to map our activities to nouns and verbs. Verbs that will act upon this, like view, list, but we need to group it to, resource life cycle. We call it resource life cycle, which is adding, deleting. You are managing the life cycle of the resource. And this is, to discover this action, we need to have it as an HTTP. Yes, we know add. What I will use for add? Post, get, delete. Which verb that I have to combine to achieve this goal? So the verbs here, the most common, as you know, get, post, put, delete. And we have options, we have head, we have batch. So the big difference between, was a question for some intelligent guy. It was nice. So what if I would like to fetch data, but I don't like to return the payload, and I would like just to know, is this resource exist or not? Use head. Head doesn't include any payload, just it will return you 200. I'm asking about specific order, 200 exist, but I don't need the whole payload. So saving bandwidth. So this is like how I can use head. It's similar to get, but just for status. No payload involved. And you can ask me about the others also, because we have exceptional cases to use post without get and instead of get in some cases for security, for things. So if you need any questions. So now getting back to my paper, and I have pen, and I would like to map. I have item resource, I have activities, and I would like to map it to verbs and nouns. And this is a very simple, you can have it in Word document, you can have in Confluence, whatever it is. So list items, get/items. And I use always plural, don't use singular. And don't use the verb get items, because I see it, like get underscore items. Okay, you have the verb. If I read it, it's get items. And why items? Because usually, even it's one item, I get all the items. What if I want to get a specific item? This is how I get it. I use get, and I use item, the same URL, and I will put, it means, please get me the specific item with number 1 or 2 or 3 from those items. Do you see how I interpret it? Then your customer will have this kind of, principles and agreed upon way of reading. This is self-documentary. Search, yes, we use exclamation mark, and we have different way to search. We can combine, but be aware that you have a limit in the URL. For search, 255, because you are using get, but sometimes we use post to have more, or just the main search items and criteria in the get URL, but if I need to customize more, I will send it as a post or as a JSON payload. Add item, definitely post, because I'm creating a new resource. You can see that at the end I have only one URL, but with different verbs, different combination, I'm just getting more functionality. And if I would like to edit, I will use put, sorry, not pot. And I have this problem. I know how to pronounce B and P, but I always mix it. So don't get confused when I do this. So I can hear like, yeah, please edit this item specifically inside those item resources. So this is how I do it. Now I get all the item resource lifecycle mapped, and the URL is great. I didn't go further even in some other details, but I have the contract. This is what is very important. And then I have cart. We have add item. Yeah, item is a different resource and cart is a resource. What is the relationship between them? We will see later on. Remove item. Similar, involve two resources. We have to understand the relationship in order to put which one is the first, which is dependent on what. This is very important. The list of the resources. Clear cart, I'm talking about specifically cart, so it's easy. Delete that cart ID from the carts that I have. And view cart, yes, I can normally get it from all the carts. I have specific cart ID. And check out, this is a process. Involve many things: notification for payment system, processing the order, acknowledgement, checking, sending an email. So this is a process. How can I write it down, even a URL? Yes, it's a check out the cart, but as a URL, it's not like post carts. Doesn't make any sense. We will see how to name this. And for orders, it's pretty the same. We don't have specific because I'm listing orders, obtaining order status, and cancel order. Finally, at the end, it's one URL, by the way. And just you are adding to that URL to get some other meaning. Changing the verb even. What is the difference between the first one and second one? It's just the requirement. The same URL serving both purpose. If you are obtaining the order or checking the status, it doesn't matter. So I have the same URL serving both requirement. And even the last one is the same URL, but just I'm changing the verb. Delete. Customer is the similar, viewing, searching, adding, and editing a customer. Let's see, to complete our cart and items, we need to understand the relationship. And mapping remaining activities to those actions, it requires us to understand the relationship. All of you worked with database, right? And when we do normalization or master details or weak entity and master slave, like main and not slave, and detailed project, this kind of term is not nice to use. Master slave, like GitHub, we changed master to be main. And we have to understand the design relationship. It's a similar concept. The design here, you have to ask yourself, are they independent? It will come to you. Is it sub-resource or main resource? I can manage the life cycle of that resource independently, or it has relation with something else. Additional information has to be provided in order to process that, sub-resource. So this is the main key about main resource and sub-resources. So, or they are associative. So let's have some question for ourselves, like I always ask myself, can the resource exist without one another? If it's yes, they can show in any order, doesn't matter, but they have relation. Does one resource only exist when the other exists? Okay, it's dependent. It will never come first. It has to come second because it depends on the first resource. Does the relationship between the resources require more information? Yes, sometimes I need a specific order to get a specific item from that order. So I need more additional information to get specific, because I cannot say from cart get this item. Which cart? Small example. We love movies and we are in cinema, so we would like to list movies. I would like to list all the actors who were playing this movie, and all the character has been played in that movie, and vice versa, which I need to get specific actor, all the movies or a specific movie run by this actor, and all the characters has been played by that actor. You can see that character is never happened to be at the first, because character is just depend either on the movie or the actor. But actor with movie, I can come first or second, doesn't matter, we are independent. Taking from this perspective, come here, you can find this is the final process. So we can post, definitely add in a specific cart with a specific ID this item with item ID. And delete will do the same purpose, same URL, just changing the functionality. And check out, you see, I check out the process. It's a name to describe what is the process is pay, check out, validate, or based on generate report. So because it's a process, it's not related process that act upon this kind of functionality. So for this point, I can give my contract to my colleagues and team in order to work for it. To validate your API, it's pretty easy. I'm just, as you know, I was using sticky notes or some papers. I'm shuffling them, making sure about the requirement. I get to the customer to show him. He said, hey, there is something missing here. I was telling about this, like, what did you told me? I told you about that I want to handle missing order, man, and it doesn't show. How can you handle this? Okay, let me check how I can do it. And also, what if I want to order the same order and cancel part of the order? I don't want to cancel the whole order. How can I achieve this? So okay, one note, I will check my API and see if really I can serve this first before introducing something new. So this is what I will do. My order is missing, so the customer service list customer order. We have an API to do that. Customer service obtain the customer status order to see if the order is missing or not. We have functionality to do this, so we don't need to develop anything. Just how the way that we order the APIs, we can achieve the functionality. Reorder, customer view, previous order, he can. Customer copies order. This is new. I don't have this functionality. So I have to develop this new functionality as an API. Checkout, I have the functionality. I don't need to develop it. Part of my order missing. Customer service listed the order. Customer service view the active order. We have an API to do that. The customer service cancel a specific order. We don't have this. And this is how I validate my API. So quickly to review why HTTP, because you know HTTP is the base for the REST API design concept from the beginning, but we usually, and it's the much easier protocol and the most common protocol that understood by tools and human and everything. So we have a pretty understanding, but REST is not a standard because we never had a standard for it. It's not like a soup. It's a pretty common agreed upon principles, as I would like to say. And REST is not a pretty URLs, people think JSON or XML, it could be binary, it could be whatever it is. The payload, it doesn't matter. It's not just, hey, I have URL, I return payload, done, REST API. No, it's RESTful. Really? We will see. REST is generally agreed upon some principle and constraint. We will see the constraint at the end. We are now designing the principles. Same like the difference, because it's always like, okay, I will use SOUP and they are similar, and no, they are not similar. SOUP versus REST is like mortgage like borrowing $10. If you buy a house with mortgage, you have to list set of documents, go to the bank, apply, they have to process it in order to accept your request to give you a house. You start paying and you have this order. You cannot reorder it or do it in some others way. And if I borrow you $10, you can give me one time $5. You can invite me for a coffee. I will accept that if you would like to do this. But we have free coffee, so I will not take from you money, don't worry. And you can give it to me at any time. It's no problem. You don't have a specific order. This is what we did when we were validating our API. We just reorder and then we accomplish the functionality at the end. What most important in the payload, so we don't have to consider all the status code, all the attributes. There is like 3 attributes really, really important to take care of, or even to include in our design when we design the payload. Those are definitely something in the headers, which is information that is hidden from user. You cannot read it, but tools already have all of them. You have it in Postman, for example. Sorry, So I'm running out of time, so I'm trying to give you. So something we have to take care of the content type. This is very important. So it gives us impression what the content type is returned or what I'm expecting from you. Status code to know what is the status of my request. And finally is the media type. This is give me a way to describe my structure of the payload, how it will look like. Response codes, don't ever think about you try to use something vague or something. Yeah, it's cool to be different, but we use always this kind of 100s, 200, 3, 4, 5, and not all of them. We usually use in 200s for OK 200, 201 for created, 202 accepted. This is the general agreed upon codes even between the in documentation and all the big companies or providing services. So when you read it, they have to give you 200. You don't even to read. You are expecting what should be done. And for 300, you use those for maintenance and moving your API or domain or something like that. And for 400, you use only those. They're just enough to serve all your APIs. And there is a big difference between 204 and 404. 204 means no content. The resources exist, but no content. 404, because this is confusing developers, mean you are asking for a resource that does not exist even. Response code are great, but please do not create your own. Last thing, the constraint, which is make your API rest. Great, I hope so. I will run in this, but I would like to give you an idea. In order to make our REST API restful, actually, we have to consider this. Client server, web browsers and web servers always work like this. Separation. And by separating the two, we can vary them. Definitely, you can have more clients. You are not tied to just web application. You can just serve many other clients. And the web application definitely could scale, the backend could scale without any kind of, headache to render or doing, or specifically, tied to a specific customer or client. And this is serves scalability and reliability, definitely. Stateless, which is very important, we don't maintain session for the user at all. This is why we are using JWT or using OpenID Connect or whatever it is. You always send your identification. Why? I don't need to maintain the user. Because if you maintain it, means there is no resilience, there is no scalability. You have to stack, migrate, you have information, and REST doesn't serve. REST, request, response, done. This is how you can shuffle your APIs. It doesn't require any state from the user to maintain the order. You don't have orders. You can mix your API to have a specific goal. If you are not stateful, you cannot do this. So stateless API, each request stands on its own, as I told you. Request can be processed in any order, and because sometimes they will have to do. So this is if you are using Twilio API for communication or for making phones, as I told you, are using JWT or some authorization token or something like this to prevent any kind of stateless. I don't know the user, it's valid, this is what I would like to achieve. Stateless why? Flexibility, stability, and reliability. It's very important. Caching, I will not speak too much about caching. Each API has its own cache, but we usually, this is improved network application usage and make system more reliable and scalable. And cacheable, it's always git, put, and delete could be idempotent and could be cached. You don't have to process the request all the time, but for post, you cannot do this because it's creating always resources, changing. We use e-tag signals. This is very easy to have and it's pretty common. GitHub always use e-tag signals and you can find it in your API like this. Layered system, you don't rely on your backend. You have domain name, you have independency, and when you have the independency, you can add more functionality on the go. And to allow in between system and remove load balancer, caching, logging, compression, all of this. Code on demand, this is something that I will tell you later on, but the last one and the important one I would like to talk to you, it's uniform resources. We talked about one, it should present in every API, and it's complex but most powerful. First, identification of the request. What does it mean? Use a proper naming conventions for your API. Your customer will always understand your API with this. Don't combine, don't mix. The second, manipulation of the resources through representation, which we call it, manipulations through these interfaces. So you have less API, you have less documentation. You use Git. This is Twilio API. Use Git for all. Post only for calls and SMS. Put for nothing because you cannot edit calls or something. You delete only recorded. Pretty small, and the whole company running on these 3 APIs. Finally, self-descriptive. Yes, if that resource is cacheable or not, its process itself, how it requests the next resource, and this is very famous thing that when we use hate use, using this example, it means that when I'm requesting a status about my, just 1 minute, and I'm so sorry for this because I lost 15 minutes. And this is the final part. When I'm requesting a functionality to see my account, it's really better to have more functionality as a links. You can withdraw, you can do this. You give me as a link. As a developer, I don't have to consult your API documentation to know what's next. I can see there is new functionality. I'll just assign it to a button and will continue working with your functionality. So I can add my functionality on the go. I can change my URLs. You don't have to worry about this because I included everything for you. This is very powerful technique that we have. This is GitHub. When you call it, you have everything. And using this constraint and the design principle, we have reached our goal of this talk. Thank you for being patient. I have to run. Thank you for your attendance. I'm glad, and thank you for your patience for the first 15 minutes.